You ever stop and think about the fact that we kind of have a superpower? I mean, we can literally peer through skin and muscle to see the very bones that hold us together. We've had this power for over 100 years, and we call it the X-ray. Today, we're going to pull back the curtain and see how we make the invisible visible. I'm sure you've seen an image like this before. It's a standard chest X-ray. It's this ghostly silhouette of our inner world. You can make out the ribs, right? The dark spaces where the lungs are, that faint shape of the heart. But what are we really looking at here? Because it's not a photograph, it's a shadow, cast by a type of light our eyes just can't see. So that's the big question we're tackling today. How do we create this incredible internal map of the human body? Well, to understand the machine, we actually have to start by understanding the image itself. So how do we read this map of shadows? The secret, it turns out, is all in the different shades of black, white, and gray. Each one tells a story about what's going on inside of you. The whole idea behind reading an X-ray is actually pretty simple. The machine shoots a beam of this special radiation, and different parts of your body block it or don't block it. Dense stuff, like your bones, which are full of calcium, they block most of the rays, and that's why they show up as bright white. Softer tissues, like muscle and fat, they let some of the beam get through, so they look grayish. And then you have air, like what's in your lungs, which offers almost no resistance at all. That's why your lungs look black. So the fundamental rule is this simple. The denser the stuff, the whiter it looks on the X-ray. If you can just remember that one thing, you're already well on your way to understanding these amazing images. Okay, so we've cracked the code of the image, we get what the shades mean. But what about the machine that actually creates it? Let's take a peek inside the hardware that makes it all happen. You know, when you boil it all down, a standard X-ray machine really has two essential parts. At one end, you've got the X-ray tube. Just think of it as the shooter. It's the part that makes and fires the X-rays. Then, at the other end, usually underneath the patient, you have the image detector. That's our catcher. It's designed to grab whatever radiation makes it through the body to create the final image. All right, now let's zoom in on the real heart of this thing, the shooter, or what's officially called the X-ray tube. This is where all the magic really starts. So inside all that big, bulky equipment is this, a vacuum-sealed glass tube. Yeah, I know, it might not look like much, but this little device is incredibly powerful. It's built to take tiny particles and accelerate them to create the super high-energy radiation we need to see right through a person. To get how this tube works, you really only need to know about two parts. On one end, you have the cathode. It's negatively charged. Think of it as our starting line. And on the other end, you have the anode. That's our positively charged target, so it's the finish line. The whole game is just about getting from that starting line to the finish line. So we have our starting line and our finish line. Now for the fun part. How do we get from one to the other and, in the process, create a beam of invisible X-rays? Well, it all goes down in a pretty cool 4-step process. Okay, here's the play-by-play. First, an electric current heats up a tiny little filament inside the cathode, kind of like an old-school light bulb. Second, this intense heat basically boils off a cloud of electrons. Third, a huge voltage difference acts like a giant slingshot, launching these electrons at an insane speed across that vacuum tube. And finally, step 4, the most important part. Those electrons slam into the anode target. That violent crash forces them to suddenly release all their energy in the form of X-rays. And this right here shows that whole process perfectly. You can see that stream of electrons just firing from the negative cathode and smashing into the positive anode target. And that impact, boom! That's what generates the cone of X-rays that's gonna pass right through the patient. It's just a beautiful piece of physics in action. So, we've created the X-rays, we've sent them on their journey through the body, but how do we actually capture the ones that make it all the way through and turn them into an image we can see? Well, that's where our catcher, the detector, comes into play. You know, back in the early days of X-rays, this was all done with photographic film, just like an old camera. But today, we use something way more advanced, a flat panel detector, or an FPD. The best way to think about it is like a really, really sophisticated digital camera, but instead of seeing visible light, it's designed to see X-rays. And what's amazing is the technology that's packed inside this thing. I mean, if you look at the diagram on the left, you can see these super intricate layers of the sensor. The top layer is a special material that grabs the incoming X-rays and turns them into visible light. Then the layers underneath take that light and turn it into an electrical signal. And all of that complex engineering is packed into that simple, thin plate you see on the right. the payoff for all this engineering is just incredible speed and clarity. Those electrical signals from the detector are instantly turned into a high-resolution digital image. There's no more waiting around for film to develop. A doctor can literally see inside a patient in real time, which allows for way faster, more accurate diagnoses when every single second counts. And the level of detail we can see is just astounding. From spotting a clear break in a bone to examining the delicate, complex structures of the human skull, the whole process gives us this extraordinary window into ourselves. And it all starts with just firing some electrons in a vacuum tube and ends with capturing a digital picture. So in the end, what we've really done is harness an invisible part of the universe to reveal the hidden world that's right inside of us. It's a true superpower of modern medicine, and it was all born from a deep understanding of physics. It really makes you wonder, doesn't it? What other invisible forces are out there, shaping our world, just waiting for us to build the right tools to finally see them?